everyone. This slideshow is particularly long, and I apologize, but it'll help you navigate some of the information as an introductory to environmental geography. So let's get started. The first thing is there is an activity this week that you can do. It's notes on this particular slideshow. And my belief is that note-taking is a fundamental skill for college. And according to various studies and me, it's just really a good way to learn and recall material. And so in order to do these activities, you'll need a pen, some paper, colored pencils, markers, highlighters, all that good stuff. Notice I didn't say a computer and Word and typing. No, these are what I like to call illustrated notes. It's not just a cut and paste thing. It's a free-flowing, free kind of drawing, interacting with the material. And so in my opinion, like I said, it's really important. It is hard work. There's, so I would recommend not procrastinating and waiting until the last minute. They are optional. If you don't want to do notes, you're not going to get a 0 for not turning them in. Also, if you turn them in and they're not really up to my rubric, I'm not going to give you a failing score on the assignment. I'll just excuse you from doing it. So yeah, the rubric involves looking at content. So how much information is there? Do you have explanations? Do you have examples? Is it organized? Or are you doing like question-based stuff? Are you putting boxes around stuff? You shouldn't have sentences or paragraphs. You should highlight major concepts. Are you interacting with it? So are you personalizing it? Are you making it creative? Are there lots of reactions? Are there tons of pictures and diagrams and charts and probably going to be maps and things like that? And then the last one is neatness. So you want to make sure that they're legible. There's not a lot of empty space per page. You really want to make it condensed, but also something that allows you to very quickly find the information if you need. So here's some examples of various note-taking activities that students have done in the past. So let me pick out some of the important things. So the big words, the words that are important, like the Big Bang Theory is like really big, right? They have made glaciers and then have arrows and things like that. They've used lots of colors and they've drawn images and things like that. So that's what I'm looking for your notes whenever I give a note-taking activity. Again, it's graded on a 4-part rubric. So content, organization, interaction, and neatness, which we call COIN. All right, there's also some resources that I've provided. These slides are in the module for the week. So that you can access the variety of notes and things like that. So, all right. So we start with what is environmental geography. So environmental geography is interdisciplinary, which means it kind of takes all these different disciplines, the history, the culture, the location, the biology, and really looks at the interaction between the biotic and the abiotic. So the living, the biotic, and the abiotic, the non-living, things like, rocks of the environment, with a special focus on the impact it has on humans. That's what separates it from like environmental science. The environmental scientists are only interested in the science. Environmental geographers are interested in the impact that humans have on that system, or the impact that system has on humans. And so we're looking at all of the aggregate information, the history, everything that influences that particular individual, community, or area. And within environmental geography, we have the 6 levels of organization. Oops, sorry. Starting with the individual. An individual is something that's within the same species, which means it can reproduce. So it has to be the same species in the same area, and if it's the same species, then they're capable of reproducing with one another. A population is a number of them. So an individual is like one elk, and a population is like an elk and all of its other elk, right? A community is defined as the populations of 2 or more species within the same area in the same period of time. So then we're talking about the elks and the bears and the bunny rabbits, all that stuff, all the plants, all that stuff. Then we go to the next level, which is an ecosystem, which is going to take in all of the biotic, all of those lives that were within the community, and also all of the non-living, the abiotic components, such as the water, the air, the rocks, things like that. And then to go even bigger, we have a biome. And so a biome is an ecological area with similar climatic conditions, and a biome probably has multiple ecosystems within it. And then, of course, there's the biosphere, which includes everything that's alive, along with all the spheres that it interacts with, like the lithosphere, the hydrosphere. So the biosphere is all of the living, whether it's alive or dead, meaning previously alive things, not, a rock. But it also includes the interaction between all of those living things and the lithosphere and the hydrosphere. All right. We will be talking a lot about the scientific method. We do a lot of talking about the geographic inquiry model, but it's based kind of sort of loosely on the scientific method. So you need to be familiar with what are the steps of the scientific method. So you start by seeing something out in the environment. You're like, why is it sunny? And then so you ask a question, and then you form a hypothesis or something that you can test, and then you make a prediction, and then you test that prediction by making an experiment. And then you're going to, iterate that, figure out the results, collect the data, analyze the data, all that stuff. So there are 6 steps really to the scientific method. The first one is, coming up with finding out what you're going to investigate. Excuse me. And then you ask some sort of question. What is the relationship between plants and whether or not they're green or not, right? And so then you come up with a hypothesis. Plants turn green because they have plenty of water, right? My toaster doesn't work because it's not plugged in, right? And then you do some sort of experiment. You test whether or not your hypothesis is true, and you ensure that only your independent your variables only change, only those things that you're looking at, not the control variables. So you want to make sure you isolate the one thing. So for example, if we're looking at what helps plants grow, and you say it's the amount of sunlight they get, then you have to make sure it's the same plant and it's the same, soil, and it's the same size pot and all that stuff, and all you're varying the same amount of water and the same amount of fertilizer, but the only thing you're varying is how much sunlight it's exposed to on a daily basis. And so you would repeat your experiment as many times to make sure your results are reliable, and then you want to make sure that you follow the same method, and you always put this into like a little notebook and all that stuff. Right. Then you're going to tabulate and analyze all your data and create all these charts and graphs and all that stuff. And then you're going to go ahead, of course, and tell everybody about your project and summarize it and make posters and PowerPoint presentations and, include, information from your report and stuff like that. So, all right. Then we have the 5 themes of geography. This dudish guy here is Mr. Help. And that's a mnemonic device for remembering the 5 themes of geography, which are movement and region, Mr., and then human environment, interactions, location, and place, help, H-E-L-P. So what is movement? Movement, when we talk about the 5 themes of geography, we're talking about how geographers, look at and make sense of the world. So the first thing that geographers are really interested in is, how and why places are connected. So we can talk about how ideas get from one area to another, or a trend, or we can talk about immigration or resources, like why are there some resources in some places and not in other places. The next theme of geography is region, and there's 3 different types of regions. There's formal regions, which are boundaries that we agree upon, like a state or a country. There are functional regions. They're made up of a central place and all of the areas that are surrounded by it. So back in the old days, it would be like a milk route or an urban area, or, the T-Mobile coverage area. And then we have something we call a vernacular region, which is like how we refer to a place, like an area that's been identified based on people's perception of culture. So like the Middle East or Southern California, right? When you think of Southern California, you think of, palm trees and movie stars and stuff like that. The next one, the one that we're going to probably spend the most amount of time talking about in this class, is human environment interaction. And it's a 2-way street. So what do I mean by that? How do humans impact the environment, and how does the environment impact humans? You're like, the environment impacts humans? Well, yeah, you certainly wouldn't want to wear board shorts and a tank top if it's 12 degrees outside. Like, you get really, really cold. Like freeze body parts that you'll never get back. So, or the fact that we depend on the environment for food and, and shelter and natural gas and all that good stuff. We also modify the environment. We create dams and things of that nature. So here's a picture that is, talking about the Folsom Dam or Folsom Lake. And you can see in 2011, it was, really super full. It was so full, they were, letting water out of the spillway. And then, just 3 years later, it's all dry and there isn't a lot of water in Folsom Lake. And so we talk about a lot of things. We talk about the sustainability of, ecosystems and the ecology of an area. So with sustainability, we try to understand how human activities can exist without disrupting the ability for the natural ecosystem to function. So throughout this course, we'll talk a lot about sustainability. It's also important when you talk about sustainability, to talk about governance. So governance considers how people make decisions and how those decisions are constrained by external forces, and how sometimes those external forces, limit or create just a range of options. So in understanding the human environment interaction, we look at the way people make decisions regarding the natural environment. For example, a farmer in Brazil participates with the governance by, dealing with, law, like the government or other community members, or, the market. And the decision that results in the transforming of the natural environment a lot of times is influenced by the government and what you can and can't do. So for example, going back to, Folsom Lake or, water in California, we are naturally it should not be able to support the number of people who live here, but because we're able to import our water from various locations, Colorado River Project, the California Aqueduct, which comes from the eastern side of the Sierra Nevada mountains, so there's a lot of different reasons why we're able to support these people, but really we shouldn't be able to do this. but because we're able to import that water, we can do that. And so a lot of times we look at the ethics involved with, prioritizing the environment over human needs, or human needs over the environment. And so we'll be talking a lot about the human environment interaction throughout this course. Another theme of geography is location, and location a lot of times is confused with the one that I'm going to talk about next, which is place. But location is where something is, and there's two different types of location. There's an absolute location. So, in geographic terms, we're talking latitude and longitude. But typically, you don't go, hey, meet me at 33 degrees, 49 minutes, 11.2 seconds north, and 117 degrees, 55 minutes, and 7.1 seconds west, right? You would say, meet me at Disneyland, or meet me at 1313 Harbor Boulevard, which is Disneyland, right? So you wouldn't give a latitude and longitude, but geographically speaking, geographers a lot of times will refer to a location using latitude and longitude, the equator, Location can also be relative. So what is it located nearest? It describes a place with respect to the environment and the connection to other places. For example, maybe this place is we're 12 miles from the Pacific Ocean, or 30 miles from Los Angeles, right? So, I like to think of this as how you would describe where you're at, or where the place is in relationship to something that someone else would know. So Chaffey College is, west of the 15 and north of the 210, right? So somebody would go, oh, okay, I get a general idea where that's at, and I can, find it, And then there's place, and the reason why a lot of times students and others get place and location mixed up is because you don't go, hey, what's your location, when you want to go visit a friend. You go, hey, let's meet at your place, right? But place in geographic terms is, the physical and human characteristics of the location. So physical characteristics include the mountains or rivers or the beach, or what is the topography, things like that. So, if a place is described as hot or sandy or fertile or a forest, these all paint a picture in our minds about what we're going to see when we get there, right? Human characteristics are another form of place. Things like, what is the livelihood? How do people make money? What is the predominant political system? What kind of common foods are there? Is there any local folklore? It can be described as, the French-speaking democracy with the Catholic majority, right? And so those would be the cultural characteristics of your place. All right. Now, geographers, because they didn't want to really feel left out in the whole science world, came up with something called the geographic inquiry model. And so the geographic inquiry model has got 5 steps, and I've always called them AAEAA, which sounds like a whole bunch of vowels, because it is. But the first step is to ask a geographic question. Why do these particular trees show signs of stress, right? Or what does it matter if a whole area is cleared of its trees? Or where are things? How do things change between here and there? And then the next step is to acquire resources. So, we might want to figure out, what period of time we're talking about. And, are we looking at, country level data? Are we looking at just local data, right? So now we're talking about data, what are we going to need in order to, answer the question about, why do these trees show signs of stress? So what could be the potential? So what is the climate? Maybe we get the weather data, maybe we get soil, maybe we get geology. So we look at the types of rocks that are underneath there, right? And then the next step is to explore that data. We turn those maps and we make maps and charts and graphs and Maps are especially valuable because they give us a really powerful tool for visualizing patterns or how things change over space. And they also allow us to integrate different kinds of data from different places. So aerial photos or satellite images and roads and rivers and like borders and things like that. And so we explore these and we combine them in different ways to try and answer why the trees are stressed in one place or another. Maybe they're on the south facing slope, and so they're getting more direct sunlight because we're in the northern hemisphere. They get more direct sunlight on the south slope. Then we're going to analyze that, right? So we're going to creatively explore the relationship between the data, between here and there, and focus on the information in the maps that seem most capable of answering our question. And really ask questions like deeper questions like, why is that? And so what? So what if it's on the south facing slope, and see if we can make some predictions. For instance, if you discover that most traffic accidents in Ranch Cucamonga occurred at an intersection along major streets running east-west, what might you expect to find in other areas? So it's the east-west streets that seem to have the problem, and not the north-south. So then you go over to like Upland and you're like, well, is that the same in Upland? And then why or why not? And then we're going to act upon that information. So we're going to take these maps, we're going to weave the knowledge we have, we're going to create information, we're going to, share that and ask that decisions are made so that, now that we have this information, it's not simply good enough to understand it. We want to really kind of take it to the next step and understand and comprehend the impact that has, and get that information out to decision makers. Now, depending on, in geography, we really only focus on breaking down the environment into 4 spheres. So like 4 regions. Geographers like to kind of group stuff together based on what it's similar to. So for example, the biosphere, which I've already kind of mentioned, that's all that stuff that's alive, or it could have been a dead thing. So like a dead frog, that's part of the biosphere. And then there's the hydrosphere, that's all the water, whether it's frozen or, things like that. And then there's the atmosphere, which is that very thin, fragile layer of gas that surrounds the Earth. And then we have the lithosphere, which is also called the geosphere, which includes all the landforms, all the rocks, all your soil. Now, also on this slide, you see that you can break these things down into further things, the cryosphere, which is all the frozen part of the hydrosphere, right? But in addition to that, in this class, we're going to talk about the interactions between these spheres. So all 4 of those spheres have individual identities, but it's important to understand the relationship and interaction between them. So environmental scientists study the effects of one sphere on other spheres. So for example, an event in the hydrosphere has effects in like a volcanic eruption, right? So you have a volcano and it erupts, and that causes, lots of issues with the biosphere, like it burns trees, and it also impacts the atmosphere because you've got a release of various gases, right? So for example, like Mount St. Helens in May of 1980, Mount St. Helens in the state of Washington erupted, right? And it altered the surrounding environment to this day. And it provided scientists with an opportunity to really study the effects of volcanic eruptions on the lithosphere, or the geosphere, right? It's a direct, a volcano is part of the lithosphere, so it's definitely going to have something. But it also impacted the hydrosphere because we got that new rock that came out, fell into the rivers and clogged up drainage, and it also impacted the hydrosphere. The atmosphere. I already said hydrosphere. Also impacted the atmosphere by, as I said, releasing gases. So there's 10 different types of interactions that occur within the Earth systems, and it's usually a series of chain reactions. Oops, push the wrong button. And so it's like this ripple effect that happens. And sometimes they can get rather complex. All right. One of the things that we'll talk a lot about is the trophic pyramid, or the energy pyramid is another name for it. And it shows the progression of food energy. At the bottom is the producers, and those are organisms that make their own form of food. So those things that can, do photosynthesis, they make their food from inorganic substances. Sorry, I don't know. All other organisms in the pyramid are considered consumers, whether they're primary, secondary, or tertiary. And so it's important to know, so your primary consumers are those things that eat the producers. So like bunny rabbits eat grass, and then the snake comes and eats the bunnies, and then the hawk comes and eats the snake, right? And so as you go up the trophic pyramid, energy in the form of heat is being lost. So those primary consumers are getting lots of energy, and the higher the trophic level, the lower the amount of available energy. And so one of the things that we'll talk about is the transfer of energy through the ecosystem. So at each level, only about 10% is transferred to the next level. So yeah, a lot of energy flows through the system, and a lot of heat energy is lost, but only about 10% is transferred to the next levels. Many people, even those who have successfully completed science courses in the past, have incorrectly or misleading ideas about some of the most important information and basic principles of science. And so I want to take some time to talk about the difference between facts, hypotheses, theories, laws, and beliefs. So my goal in the next couple of slides is really to kind of distinguish these things. And so according to the Academy of Science, some scientific explanations are so well established that no new evidence is likely to alter them. And those things are considered theories, right? And so it's like a comprehensive explanation of an important feature of nature supported by facts which have been gathered over a long period of time. So that's what a theory is, right? Like the theory of relativity. Right, we've studied it for a long period of time. It does not mean that it is, it doesn't mean it's particularly true, like the Big Bang theory. It's a theory, based on the collection. And so in science, the word theory refers to that, in everyday language, like a theory is like a hunch or a speculation, but in science, it's so much more than that. It's a comprehensive explanation. So let's talk about facts. Let's break this down. And I don't want to say it, they kind of build on each other, because I don't want to go there. So facts, let's just talk about facts. It's an observation of the world around us. For example, it's bright outside. Well, not right now, it's dark outside, but so then we have like hypotheses. So we have an observation. It's dark outside or it's bright outside. So then we come up with a hypothesis. It's a proposed explanation for a phenomenon and a starting point for further investigation. So you could say something like, it's bright outside because the sun is out, right? Or it's dark outside because the sun isn't out. Right. So then we have our theory. So it's a well-established explanation acquired through the scientific method and repeatedly tested and confirmed through observation and experimentation. And so we would say, well, when the sun is out, it tends to make it bright outside. Okay. Now, laws are usually pretty easy to figure out because they usually involve some sort of formula, like F equals ma, like force is equal to mass times acceleration, right? It's a statement based on, repeated observations that describe something. It's proof that something happens and how it happens, but not why it happens. And then the last thing is, of course, a belief. It's a statement. It's not scientifically provable in the same way that we can, prove facts or hypotheses or theories. Scientifically disproven beliefs can still be held true. Some people believe that the earth is flat, and we can use science to disprove that, but that doesn't mean that people still don't believe it, right? So a scientific theory is, again, well established, based on the natural world. It is repeatedly confirmed through observation and experimentation. They're not guesses, but reliable accounts of the real world. For example, evolution is a theory. It's just a theory. It's, the atomic theory of matter, stating that everything is made up of atoms. That's a theory. Germ theory of disease, which states that many diseases are caused by germs. Gravity is a theory. It's not a law. It's still a work in progress, but the phenomenon of gravity, like evolution, is accepted pretty much as a fact. If I drop something, it's going to fall down. It's going to be attracted to the earth, right? Okay. The earth is divided into 3 heat zones, and this goes way back to the Greeks, probably Aristotle, somewhere around there. Now you have to remember, Greece is located in what is called the temperate zone. So that's the zone that is not too hot and not too cold. They call it the temperate zone. And the temperate zone is located between the tropics and the Arctic Circle. All right. Then they said anything north of the Arctic Circle, it's frigid. It's just too cold, right? So from the Arctic Circle to the North Pole, it's too cold. We call that frigid. And then everything that's between the Tropic of Capricorn and the Tropic of Cancer, the Tropic of Cancer, which is in the Northern Hemisphere, the Tropic of Capricorn, which is the Southern Hemisphere, which you can remember because they're in alphabetical order, is considered torrid, which reminds me of the word horrid, and they called it that because it was too hot. So torrid is hot, and frigid is cold, and temperate is, those areas that are quote unquote suitable for human inhabitants. All right. We'll also talk about scale. Now, in this class, we don't talk a lot about map scale, although map scale is important. We'll talk about, looking at different things at different scales. And when we talk about looking at things at different scales, maybe we're talking about, is this a local problem? So if there's an oil spill, or a gas leak, that's probably a local problem until the St. Anna winds come and start blowing stuff, or until something else happens and it becomes a regional problem. And then sometimes problems get so big they become global problems, right? And so when we talk about environmental things, we'll be talking about these different scales. So we'll also talk about scale referring to how big or small something is, but when we talk about it in phenomena. Sorry, that's my phenomenon. Oh, sorry. So the first type of scale is spatial scale, the extent of which the area or the phenomenon phenomenon, or process occurs. So, and I've kind of mentioned that a local scale, a regional scale, a national scale, right? For example, that water pollution, it can occur at a small scale and just impact like a little creek. Or that creek could lead to a larger body of water and become, more of a regional problem, right? So spatial scale refers to the area, or what we call spatial extent, that we are analyzing and understanding. Yeah. Then there's the temporal scale. Temporal means time, not temperature. It's time. So the duration or length of this being a problem. So maybe we talk about air pollution. It often exists, at a particular time of day. If we're talking about that, like smog, right? Smog is a temporal scale thing, it's also a spatial scale thing, it's usually just a local problem. And then the last one is phenomenon scale. And a lot of times we'll talk about a phenomenon. For example, climate change is a phenomenon, and it causes problems at all spatial scales and at different temporal times. And so it depends on how we define the problem as geographers. And so we'll be talking about each of these types of scales throughout the class. Climate change, we could look at it on a global scale, since climate is a global process. However, a lot of times we look at its impact in a local area. So climate change is caused by, among other things, the burning of fossil fuels. And so because it impacts people and ecosystems in local places across the world, and it's different in different places. So, I used to say, and I still do, I shouldn't say used to, I still say that climate change is only a problem if you care where you live. There are plenty of places on this planet that we can move to if the climate becomes unbearable, if you have the, means to do so. But if you don't have the means to do so, then it becomes a problem. If you live on a small island country in the middle of the Pacific and, your island is only, 50 feet above sea level, and sea level rise is supposed to be 60 feet, means you're going to run out of space and there's going to be no island left for you to live on, right? So these problems occur on many scales, and a lot of times we have to really kind of think about all of these different things, the phenomenon scale, the spatial scale, and the temporal scale, in order to really understand what's going on. For example, when you buy seafood, do you ask yourself, where does my seafood come from? How does it get here? Deforestation is another thing that we will talk about in this class. As with climate change, it's important to discuss deforestation on many scales. So an individual living in the Amazon might decide to cut down a tree to collect firewood and to sell the wood, or clear the land for farming. And if we think of deforestation just on a local scale, then we might see it as a local event. However, the decision to cut down those trees can be connected to other economic or cultural or environmental processes. So if we cut down trees, then we're reducing the amount of carbon dioxide that's being taken out of the air, because trees aren't there to photosynthesize, right? And so we start making, incentivizing not deforesting areas, right? So we need to see that, the old phrase was, a butterfly flaps its wings in China and, it rains for 7 months in California, right? So, so one of the things we'll talk a lot about is these phenomenon, deforestation, desertification, climate change on a local scale, and how that can impact other things going on the planet. So one way to approach understanding the relationship across scales is through commodity chain. That's the word I was looking for. So this contains the links between the collection of the resource and the transformation of that into goods or commodities, and finally the distribution to consumers, right? And so different stages of this chain can also be in different economic sectors. And so, this is just one when we talk about, the seafood industry. So looking at this flow chart, we start with technology support for the resources leads to the production or capture of fish. So maybe we're going out and we're doing wild capture. Maybe we're doing aquaponics where we're, doing farm raised, fish, right? Then we have to collect them. So for what we call the first producer point. So it's almost like a trophic pyramid, only, you got the thing that you're in, then you've got the people who are getting them, and then they're going to go on, and eventually they're going to end up being sold and consumed. And maybe, some of them are like local, retail restaurants, the shopping, maybe it's going to a restaurant, maybe it's going to a retail store and you're buying it at the grocery store, or maybe it's a large scale buyer, just kind of, so we don't, talk about stocks, we can talk about, seafood demand, we can talk about mercury, and that there are certain months out of the year you're not supposed to eat like certain types of fish because the mercury levels are really high. So there are two important ways of delineating the world. The first one is longitude. Another name for longitudes are meridians. And the reason why they're confusing is they run north and south, but they tell you how far you are east and west. They're all of equal length, and they're all create great circles. So no matter which, line, whether it's 10 degrees or 20 degrees or 117 degrees, if I took that and went all the way through the earth, all the way around, I'm going to, excuse me, create a half of the sphere. And so we talk about, great circles. That means that each one of them is the same size. They're all equal in length. All lines of longitude are equal in length, which is not the same thing for latitudes, or some people call them flatitudes because they lay flat across the globe. They're also known as parallels. They run east and west, but they tell you how far north and south of the equator you are. And so they lie in plains. They get shorter towards the poles, and they're longer along the equator. And you can see that in this picture, or around the middle of the earth, it's much bigger than up here. And yet they are the same, they're latitudes. Right? There are some important lines of latitude that you should be familiar with. The North Pole and the South Pole are at 90 degrees. The Arctic and Antarctic circles at 66.5 degrees north and south. And the Arctic circle is the northernmost extent of sunlight in the winter. Cancer at 23.5, and the Tropic of Capricorn at 23.5 degrees south, and the equator at 0. So these are important lines of latitude, and you should know where they all are. The tropics denote the northern or southernmost extent of the direct rays of the sun. So the sun, from where we're at here in Southern California, we're about 33 degrees. We never receive direct rays of the sun. Sun is always in the south, or south of us, I shouldn't say. Well, yeah, I guess in the south, depending on the region. It's not always in like Texas, but meaning it's always south of us. It's always in the southern portion of the sky, regardless of what time of year it is. If you lived at 33 degrees south, it would always be to the north of you. And so here in North America, the south-facing side of the building is where you put your solar panels, because that's where the direct rays of the sun, well, that's where the most rays of the sun are going to be located. Shouldn't say direct because it's never like straight overhead. That's always at, little off direct rays. All right. I think that's all I wanted to say about that. All right, so we've talked about environmental geography. So let's talk about geography. So geography is the study of Earth and how humans interact with it. And so, as I said in the first part, where I was talking about environmental geography being different than environmental science, geographers are concerned with that human interaction piece. And so geography is typically seen as a social science. So among other things, social science courses about the natural environment. And at first glance, it might seem a little odd that if the environment is a natural phenomenon, then shouldn't environmental geography be more of a natural science? And it's unquestionably important to understand the natural environment. But what I hope becomes clear in this course is that the social parts are important also. So humans impact the environment. Human society has a very large impact on the natural environment. We are changing the makeup of the earth and the atmosphere. We're depleting natural resources. We're, modifying the global climate. We're causing many species to go extinct. And these impacts are unprecedented. And in this course, and during the course of human history, we can study the rate of change and the impact, but the social science part, the looking at human society, is also very important. So the environment also impacts humanity. Just as we have impacted the environment, has played a large role in our society throughout history. So the birthplaces of civilization were near rivers. I mean, most, societies had to have access to water. So most of the earliest developments of humans are near water sources. Like in Los Angeles, the indigenous people lived in the valleys during the winter, and and then went to the mountains in the summer. But when they did, they were always near a water source. Environmental impacts. And we've created environmental policies that have really looked at the impacts of humanity on the environment, and those policies we'll also be talking about. So this includes our policy on how we impact the environment, the Clean Air Act, Clean Water Act here in the United States. And the word policy should be interpreted broadly. It's not just a governmental thing. It could be a nonprofit, it could be a business, it could be a school, it could be your household. So understanding environmental policies is found throughout human society and requires social science. It requires us to look at what is the culture of that area, And so this course is going to cover all of these different social science and natural science ways of looking at things. One advantage of studying the environment in a geography course is that geography is a very diverse discipline, and we're very comfortable with including ideas from other disciplines. So indeed, some of the content for this course comes from natural science and the humanities, in particular ethics, and other things like business and engineering, and economics and politics. And all of those different disciplines also bring different perspectives. But ultimately, the disciplines are all studying the same world. And our goal is to understand the world and society's place within it. And we will use whatever perspectives will help us to achieve this. All right. Thank you, and have a great week.